I am Soumya of CSCP. This presentation is about instruction pipeline.
Pipelining. Multiprocessor pipelining divides work into stages, with each processor handling a stage simultaneously. As one stage completes, the output feeds into the next processor, enabling parallel execution and enhancing overall system's efficiency. Now let us understand this with an example of a busy kitchen with multiple chefs. In a multiprocessor system like a busy kitchen with multiple chefs, pipelining optimizes task completion. Imagine 3 chefs handling different stages, preparing ingredients, cooking, and plating. Without pipelining, each chef finishes one dish before starting the next. With pipelining, while one chef chops ingredients, another cooks, and a third plates. As soon as one stage finishes, it moves to the next dish, ensuring each chef is continuously engaged. This parallel execution boosts overall system's efficiency. This image depicts a control unit with 4 stages labeled Stage 1, Stage 2, Stage 3, and Stage 4. Each stage represents a step in the instruction processing cycle: fetch, decode, execute, and write back. The control unit is responsible for coordinating and managing the execution of instructions in a computer's central processing unit. It controls the flow of data and instructions within the CPU, ensuring that each instruction is processed. Instruction pipeline. The 4 stages are: FI, fetch an instruction from memory; DA, decode the instruction and calculate the effective address of the operand; FO, fetch an operand; EX, execute the operation. Of an instruction pipeline will be more efficient if the instruction cycle is divided into segments of equal duration. One of the most common examples of this type of organization is a 4-segment instruction pipeline. A 4-segment instruction pipeline combines 2 or more different segments and make it as a single one. For instance, the decoding of the instruction can be combined with the calculation of the effective address of one segment. The following block diagram shows a typical example of a 4-segment instruction pipeline. Instruction cycle is completed in 4 segments. Segment 1. The instruction fetch segment can be implemented using first in first out buffer. Segment 2. The instruction fetch from memory is decoded in the second segment, and eventually the effective address is calculated in a separate arithmetic circuit. Segment 3. An operand from memory is fetched in the third segment. Segment 4. The instructions are finally executed in the last segment of the pipeline organization. First clock pulse, first instruction is fetched. In the second clock pulse, the fetched instruction is decoded and the second instruction is fetched. In the third clock pulse, decoded instructions operand is fetched. Second instruction is decoded and the third instruction is fetched. Here the third instruction is a branch instruction. So in the fourth clock pulse, the first instruction is executed, second instruction's operand is fetched, third instruction is decoded. But here we cannot fetch instruction 4. We can only fetch instruction 4 after the execution of instruction 3. So execution of instruction 3 completes in 6th clock pulse. So after 6th clock pulse, 4th instruction is fetched. From the 7th clock pulse, 4th instruction is fetched. Later on, the rest of the operations are performed in the same order after 7th clock pulse. So all the 7 instructions are fetched, decoded, and finally executed at the 13th clock pulse. Branch instructions. When a branch instruction is encountered during the pipelining process, it may lead to a change in the instruction flow, making prior instructions redundant or invalid. To handle branches, predict the branch outcome. If the prediction is correct, continue processing the subsequent instructions. If the prediction is incorrect, the pipeline may need to be flushed and correct instructions fetched and processed from the branch target. Considering the 5th instruction, if the 5th instruction is a branch instruction, the pipeline will predict its outcome. The subsequent instruction will continue based on this prediction. If the 5th instruction is a non-branch instruction, it will follow the steps outlined for clock pulse 5 above.